You know, whenever I look up at the night sky and see the moon, well, I can't help but feel a sense of wonder. And you've sent us a whole stack of sources on it. Everything from its formation to its influence on Earth, even some cool facts about lunar exploration. So get ready because we're about to take a deep dive into all things lunar.
What's fascinating about the moon is that despite being our closest celestial neighbor, there's still so much we're discovering about it. For example, did you know there are actually multiple theories about how the moon formed?
Yeah, I saw that in the research you dug up. It's not like the Earth just woke up one morning with a moon by its side.
Right. One theory is the capture theory. Imagine the moon forming somewhere else entirely and then getting snagged by Earth's gravity, sort of like a cosmic game of capture the flag.
That would be a wild way to get a moon. I also read about the co-formation theory. That one suggests the moon and Earth were basically cosmic siblings, forming side by side from the same cloud of space stuff.
Exactly. And then there's the fission theory, definitely the most dramatic of the bunch. It proposes that early Earth was spinning so fast, like a dizzy figure skater, that a chunk of it flew off and became the moon.
Okay. I can see how that one would make for a good action movie. But the research you sent seems to point to the giant impact theory as the most likely explanation, right?
It is the prevailing theory. Picture this. The early Earth, still molten and volatile, gets sideswiped by a Mars-sized object called Theia. The impact is colossal, spewing molten debris into space, some of which eventually coalesce to form the moon.
Wow! That's a pretty intense origin story. But what makes scientists think this theory is more likely than the others?
One word: evidence. If we analyze the composition of moon rocks brought back during the Apollo missions, they bear a striking resemblance to the Earth's mantle. This suggests a shared history.
So, it's like finding two puzzle pieces that fit perfectly together, hinting at a common origin.
Precisely. And the moon's tilted orbit compared to Earth's also supports the giant impact theory. The sheer force of that impact would have sent things spinning in unusual ways.
And I read that scientists have even used computer simulations to test this theory, right?
Yes, and when they plugged in the physics of a massive impact like this, what they found was consistent with the moon's current position and composition.
It's amazing how scientists can take an event from billions of years ago and piece together a story that's backed up by evidence. Speaking of evidence, let's talk about what the moon is actually made of.
Its composition is another clue that ties back to the giant impact theory. We tend to think of the moon as being made of cheese, but in reality,
It's definitely not cheese, although that would be delicious.
right, the moon's crust is actually rich in oxygen, silicon, aluminum, calcium, iron, and magnesium. Its mantle, the layer beneath the crust, has a similar makeup to Earth's, but with more iron and magnesium.
And its core, is it also similar to Earth's?
That's where it gets really interesting. The moon's core is proportionally much smaller than Earth's, and mainly consists of solid iron. The giant impact theory suggests that heavier elements from Theia, like iron, might have sunk into the Earth's core during the impact, leaving the moon with a relatively small one.
So the impact didn't just create the moon, it actually shaped its internal structure.
That's fascinating. But enough about what's going on inside the moon. What about its surface? I mean, everyone knows it's covered in craters, but what else is out there?
Ah, the lunar landscape. It truly is a sight to behold. Imagine a tapestry woven from billions of years of cosmic events. We see craters, of course, formed by asteroid and comet impacts, ranging in size from tiny pinpricks to enormous basins hundreds of kilometers across.
It's incredible to think about these impacts shaping the moon's surface over such a long period. It's like a cosmic dartboard. But those dark areas we see on the moon, the ones ancient civilizations mistook for seas, those are called Maria, right? They are indeed. Those large, dark, smooth plains are actually solidified lava flows from billions of years ago. Imagine volcanic eruptions flooding these areas with molten rock, which eventually cooled and hardened.
So when we look at those, Maria, we're actually looking at ancient lava flows. That's wild.
It is. And what makes them appear darker than the surrounding terrain is their lower reflectivity. They don't bounce back light as much.
And they have cool names, too, like Mare Tranquillitatis, the Sea of Tranquility, where
Yeah.
Apollo 11 touched down.
They do. And in stark contrast to the Maria are the lunar highlands, these lighter regions, heavily cratered, are the oldest part of the moon's surface.
The highlands are like the moon's ancient history books, preserving billions of years of impacts.
Precisely. They're
Okay.
composed of rocks, rich in aluminum and calcium.
So we've got these darker Maria, shaped by volcanic activity, and the brighter highlands, which have been pummeled by impacts for eons. And it's all illuminated by the sun, creating the different lunar phases we see. Speaking of which, can you remind us how those work? I feel like I always mix them up.
Of course. The lunar phases. They're simply a matter of perspective. Imagine the sun as a giant spotlight. As the moon orbits Earth, the amount of illuminated surface we see from our vantage point changes, creating that familiar cycle of waxing and waning.
Okay, that makes sense. So it's not that the moon is changing shape itself, it's just how much of its sunlit side we can see.
Exactly, it's all about angles and illumination. When we see a new moon, it's positioned between us and the sun, so its illuminated side faces away from Earth. Then as it continues its orbit, we start to see a sliver of reflected sunlight, creating the waxing crescent, and so on.
And then it reaches full moon, when the entire face we see is illuminated, right? It always amazes me that the moon doesn't produce its own light, it's just reflecting the sun's trap.
It's a cosmic mirror, in a way.
Yeah.
And speaking of the moon's movement, there's another fascinating phenomenon called synchronous rotation. You see,
Yeah.
the moon takes about the same time to rotate on its axis as it does to complete one orbit around Earth.
It's like it's doing a perfectly synchronized dance with Earth.
Exactly. And that's why we always see the same face of the moon. The other side, often called the far side, remained hidden from view until 1959, when a Soviet spacecraft, Luna 3, sent back the first images.
I bet that was a huge moment in space exploration, finally seeing the other side of the moon. It's amazing how our understanding has evolved over time, especially when you think about the tools we use to observe it. I read that early astronomers had to rely on their own eyesight and some pretty basic instruments.
They did. They used tools like the astrolabe and quadrant to measure the moon's position in the sky and track its movement.
I can't imagine trying to unravel the mysteries of the cosmos with just those. Thank goodness for the invention of the telescope.
Absolutely. That was a turning point. The first telescopes, called refracting telescopes, used lenses to bend light and create magnified images. Later came reflecting telescopes, which used mirrors instead of lenses.
And those reflecting telescopes really upped our game, didn't they? I remember reading about their impressive light-gathering capabilities.
They did indeed. Reflecting telescopes can be built with much larger apertures. That's the opening that lets in light. And the larger the aperture, the fainter and more distant the objects you can see. That's why they revolutionized astronomy.
It's like going from trying to listen to a faint whisper to having a megaphone pointed at you. And now, we're not even limited to Earth-based telescopes anymore, are we? We've got telescopes in space.
We do. We've entered the age of deep space telescopes, like the Hubble Space Telescope. Orbiting high above Earth's atmosphere, it gets a much clearer view of the cosmos.
Hubble has been sending back stunning images of distant galaxies and nebulae for decades. It's incredible to think it's still up there, doing its thing. And it's not alone, is it? The James Webb Space Telescope joined the party a few years ago, right?
It did. And with its advanced technology, it's able to see even farther back in time and space than Hubble. Observing the universe in infrared light, it's already making groundbreaking discoveries.
It's mind-blowing to think about those telescopes, millions of miles away, sending back data that changes our understanding of the universe. But let's bring it back down to Earth for a moment. I know we've been talking about the moon's formation and features, but what about its effect on us here on Earth?
The moon's influence is profound, even from a distance. It's more than just a pretty face in the night sky. Its gravitational pull is the main force behind Earth's tides.
Oh, right, the tides. I always forget about that. So how does that work exactly?
Well, the moon's gravity tugs on Earth's oceans, pulling the water towards it on one side of the planet and creating a bulge. On the opposite side of the Earth, inertia, the tendency of an object to resist changes in motion, causes another bulge. These bulges are what we experience as high tides.
So it's like the moon is playing tug of war with our oceans.
In a way, yes. And the sun's gravity also plays a role. When the sun, earth, and moon align, their combined gravitational forces create even more pronounced tides, called spring tides.
That's amazing. I had no idea the moon had such a powerful influence on our oceans. But it's not just about the tides, is it? Doesn't the moon also play a role in stabilizing our planet's axial tilt?
It does. Earth is tilted on its axis at about 23.5 degrees. This tilt is what gives us our seasons, and the moon's gravity acts like a stabilizing force, preventing drastic wobbles in Earth's rotation. Without the moon, our planet's tilt could vary wildly, leading to extreme and unpredictable climate changes.
Wow, that would be chaotic. So the moon is like our silent guardian, keeping our planet steady and our climate relatively stable. It makes you realize just how interconnected everything is in the vastness of space.
Exactly. And that interconnectedness extends to the very way we measure time. Did you know that many ancient calendars were based on the lunar cycle?
That makes sense. It's a cycle that's easy to observe and track.
Yes. And even today, the moon continues to captivate our imaginations and influence our cultural practices. Think about the countless myths and legends inspired by the moon.
It's true. From werewolves to moon goddesses. It seems like every culture has its own stories about the moon.
It's fascinating how a celestial object can hold such sway over our collective imagination. But the moon's influence extends beyond myths and legends. Remember how we talked about the moon shielding Earth from some asteroid impacts?
Right, like a cosmic bodyguard, taking hits for us. And those impacts have left their mark on the lunar landscape, haven't they? I read about those intriguing features called lunar rills.
Yes, lunar rills are these fascinating, long, narrow depressions on the moon's surface. They could be straight or meandering, almost like ancient riverbeds.
But they weren't formed by water, were they?
Scientists believe they were formed by collapsed lava tubes, or ancient tectonic activity. Imagine molten lava flowing beneath the moon's surface, carving out these underground channels.
That's incredible. And speaking of incredible lunar events, we can't forget about eclipses. They've captivated skywatchers for centuries. Can you remind us how those work?
Of course, a solar eclipse happens when the moon passes directly between the sun and Earth, casting a shadow on our planet. It's as if the moon momentarily blocks out the sun.
And there are different types of solar eclipses, right? I remember seeing pictures of a total solar eclipse a few years back. It was breathtaking. The sky went dark in the middle of the day, and you could see the sun's corona, that ethereal outer atmosphere, shining around the edges of the moon.
Exactly. During a total solar eclipse, the moon perfectly aligns with the sun, completely covering the solar disk.
But there are also partial solar eclipses, where the moon only covers a portion of the sun, making it look like a crescent. And then there are annular solar eclipses. Those are the ones where the moon is farther away in its orbit, so it doesn't completely block out the sun, right? You end up with this ring of sunlight around the moon.
Exactly. It's like a celestial bullseye. And then, of course, we have lunar eclipses.
Right. Lunar eclipses, that's when the Earth gets in on the act and casts a shadow on the moon.
Precisely. A lunar eclipse happens when the Earth positions itself directly between the sun and the moon. Earth's shadow then falls on the moon, dimming its light. And unlike solar eclipses, which are only visible from a narrow path on Earth, lunar eclipses can be seen from anywhere on the night side of our planet.
And during a total lunar eclipse, the moon often takes on that reddish hue, sometimes called a blood moon, right? It's eerie, but beautiful.
Yes. That reddish color is caused by sunlight being scattered and filtered as it passes through Earth's atmosphere.
It's amazing how these eclipses, which have been observed for millennia, continue to fascinate us and teach us more about the dance between the sun, Earth, and moon.
They're a beautiful reminder of our place in the cosmos. And speaking of exploring our place in the cosmos, let's talk about how we've used technology to venture beyond Earth. From telescopes to robotic explorers, our quest to understand the universe has led to some incredible inventions.
You're talking about space probes, right? Those unmanned spacecraft that have been sent out to explore the solar system and beyond. It's mind-blowing to think about these machines traveling through space, sending back data and images that expand our understanding of the cosmos.
It is. Think about the Voyager probes. Launched back in 1977. They've visited the outer planets, sending back incredible images and information about Jupiter, Saturn, Uranus, and Neptune. Voyager 1 is even now the farthest human-made object from Earth, venturing into interstellar space.
That's incredible. And it's still sending back data, right? What a testament to human ingenuity. But it's not just the Voyager probes, is it? We've sent probes to orbit other planets and even land on their surfaces.
Exactly. The Cassini spacecraft spent over a decade orbiting Saturn, sending back stunning images of its rings and moons. And then there's the New Horizons probe, which gave us our first close-up look at Pluto in 2015. Who could forget that heart-shaped nitrogen glacier?
It seems like there's no end to the fascinating worlds out there waiting to be explored. But a lot of the focus these days seems to be on Mars, doesn't it? With good reason, too.
Absolutely. Mars has captivated our imaginations for centuries. And now, with rovers like Curiosity and Perseverance exploring its surface, we're closer than ever to answering that age-old question. Was there ever life on Mars?
It's an incredibly exciting time for space exploration. Those rovers are like our eyes and ears on Mars, sending back incredible images and data. What are some of the most significant discoveries they've made so far?
Well, Curiosity has found evidence of ancient lakes and rivers on Mars, suggesting that it once had a much warmer and wetter climate than it does today.
So there really was water on Mars.
Yes. And not just a little bit. Evidence points to vast bodies of water that existed for long periods of time.
That's incredible. What about Perseverance? What has it been up to?
Perseverance is searching for signs of ancient microbial life. It's collecting rock and soil samples, which will hopefully be returned to Earth by a future mission.
It's like something out of a science fiction novel, except it's actually happening.
It is. And these missions are just the tip of the iceberg. There's so much more to explore, not just on Mars, but throughout our solar system and beyond.
That makes you realize we're living in a golden age of discovery.
We are indeed. And who knows what the future holds? We might one day find evidence of life beyond Earth, or unlock the secrets of the universe's origins.
It's both exhilarating and humbling, don't you think?
Absolutely. There's a sense of awe that comes with studying the cosmos, a reminder that we're part of something much greater than ourselves.
And speaking of awe-inspiring sights, I was struck by those images of Jupiter's swirling clouds and Saturn's magnificent ring.
They are breathtaking, aren't they?
Yeah.
Those images remind us of the beauty and grandeur of the universe we inhabit.
They really do, and they make me wonder, what other wonders are out there just waiting to be discovered?
That's the beauty of science. It's a never-ending quest for knowledge. Each discovery leads to new questions and new avenues of exploration.
So true. So, as we wrap up our lunar deep dive, what's the key takeaway you'd like to leave with our listeners?
Well, I'd say never lose your sense of wonder. Never stop asking questions. The universe is full of mysteries, and we're incredibly lucky to be alive at a time when we have the tools to explore it like never before.
Well said. The universe is a vast and wondrous place, and it's up to us to keep exploring it. Thanks for joining us on this lunar deep dive. Until next time, keep looking up.